There's many different ways to build stream ciphers, and if you squint carefully, you could argue that AES-CTR is a stream cipher. The top half of this encryption diagram is using block ciphers to generate lots of pseudo-random output, and then using that as a pad in the one-time pad scheme. So arguably, this is also a stream cipher. Stream ciphers can be shown to be IND-CPA secure as long as you assume that the pseudo-random output is secure, and the proof is pretty similar to the proof that we did to show that one-time pads are secure. A very minor footnote is that you have to be careful not to encrypt too much data at once. So don't encrypt a message that is obscenely long. For example, if you do so in AES-CTR, you might cause the counter to wrap back around, and that would cause you to start reusing the pad and break some security. So it doesn't really happen often in practice, but do be careful not to encrypt something that's so big that it causes the AES-CTR counter to wrap back around to 0. That would be bad. One benefit of stream ciphers, as the name implies, is that they support streaming. And what that means is that you can encrypt and decrypt additional data as it is coming in. So for example, let's say you've downloaded half of a really big file. Well, what you can do is you can generate enough PRNG output to decrypt the half of the file that you currently have. And if later the other half of the file is downloaded, you can just take the PRNG and continue generating bytes wherever you left off, and the PRNG will generate more bytes, and you can use those to decrypt the second half of the file. And likewise, if you're encrypting data, but you don't have all of it right now, you can run the PRNG to encrypt what you have now, and if additional data comes in later, you just have to keep running the PRNG. It will continue generating output wherever it left off, and that allows you to encrypt the rest of the data that is streaming in. So that's a useful benefit of stream ciphers. Another benefit of some stream ciphers is that they let you encrypt or decrypt an arbitrary chunk of the message without having to process the rest of the message. So for example, maybe you have a 1 gigabyte ciphertext that's really big, but you only care about the last 128 bytes. Some stream ciphers will let you skip to the end and only decrypt the chunk that you care about without having to process the rest of the ciphertext. So for example, AES-CTR does support this. If you only want to decrypt the ith block, all you have to do is take the nonce, concatenate it with the number I for the ith block, pass that into block cipher encryption. That's the corresponding pad for the ith block. You can XOR the ciphertext with that pad and get the original plaintext back without having to process any other part of the ciphertext, which is kind of nice. Some stream ciphers, though, don't support this. So for example, if you're using the HMAC-based stream cipher and you want to decrypt the last block, you would have to generate the PRNG output all the way to the last block, because the way that the PRNG works is it calls HMAC over and over again. So if you want the last block, you have to call HMAC a lot of times to generate the PRNG output all the way up to the last block. So you can't arbitrarily skip to the end, unfortunately. But some stream ciphers, they do have this benefit. And so that's it for stream ciphers, and now we can finally move on to Diffie-Hellman key exchange.